My name is my name is Florence Lowlee, and I'm the president and the founder of the Global America Institute. I would like to welcome you to today's program discussing the issues and challenges of the NRC licensing process of the advanced nuclear reactors. Most recently, NRC has completed the design certification application process for NuScale's small modular reactor, and this was the first ever the NRC has issued a final safety evaluation report for an advanced reactor design, and the NRC is now preparing a rulemaking to certify the design. Once it is certified, the NuScale's SMR will join 6 other reactor designs so far certified by the NRC, including Korea's APR 1400. It is exciting to see the first of a kind design, but it also comes with some barriers and some problems and some uncertainty, some obstacles, which some of them will be addressed by our 2 outstanding speakers today. We have Dr. Meserve, a former commissioner of NRC, and Mark Nichol, who is in charge of new reactors at Nuclear Energy Institute. And the program will be moderated by another expert from Argonne National Laboratory, Paul Dickman. The format of the program will be sort of a fireside chat and followed by Q&A. Before I turn this to Paul, I just want to remind our colleagues and friends joining us from Korea, Japan, and other part of the world that daylight saving will come to an end this Sunday. So if you are joining Gabby workshop in the next week or so, just to take into consideration, there will be a time difference. So it'll be 14-hour difference between Washington and Korea and Japan. So now with that, I'd like to turn this over to Paul Dickman. Paul, make it fun and exciting.
Oh boy, that's a challenge. Thanks. Well, with that, first of all, we have two great speakers, and I really appreciate both Dick and Mark participating in this. You have their bios in the invitation, but it bears repeating again that Dick Meserve was the chairman of the NRC, and during a very important and transformative time, which was during 9/11, which was an extraordinary time. So, and Mark also heads up the NEI industry working group that is looking at the exchange interface on Part 53 with the NRC. So with that, let me start off by asking Dick to give a few remarks, and we'll go from there.
Thank you, Paul, Florence, and Mark. It's good to see you as well this morning. What I thought I'd do to start us off is just to try to set a context for our discussion. As I think as many on this call know, there are about 50 or so vendors that are talking about the possible introduction of advanced reactors of various different kinds. And they are very intriguing because they promise to lower cost, both in terms of cost of dollars per kilowatt hour, but also the actual sticker price to acquire a plant. They promise greater safety, technical simplification through passive safety mechanisms, possibly higher temperature operation that gives you greater thermodynamic efficiency, as well as opportunities for process heat, greater fuel efficiency with longer lived cores in many cases, less waste production. In principle, many have greater non-proliferation protections. Of all these, probably for the U.S., the most essential ingredient is beyond assuring absolute the necessary safety protection is lower cost. That really is what is going to determine whether these succeed in the marketplace or not. And as all of us know, paper reactors are always cheap. It's with the test comes forward and actually building them, but they hold promise that they will be able to achieve that. One of the challenges in cost is the regulatory challenge. It's how long it takes to the detail that's required to file an application and have it reviewed. And there is a severe regulatory challenge, which we're going to discuss this morning, because many of these reactors use non-light water coolants. And we have a particular challenge because the existing regulations, principally Part 50 and 52, are prescriptive. They're focused on light water reactors and have many regulatory requirements that are applicable to light water reactors, but may not be applicable to many of these advanced reactors. So you have this challenge that you have to proceed with licensing with great uncertainty as to what regulatory requirements you have to satisfy. And that's a huge challenge for these vendors because they need to have some confidence that they know what the regulatory burdens they're going to confront. And to know those early enough so that they can turn off investment before they've made a huge investment, and hopefully can tailor what they submit to specific regulatory requirements. So they need early guidance. And there is emphasis in some legislation, I'm sure we'll be talking, to push the NRC towards staged licensing to the extent possible so that early guidance can be obtained. There are great opportunities with some of these advanced reactors to greatly reduce cost, which, as I've indicated, is a crucial ingredient. The safety systems can be simpler, particularly with passive safety systems that eliminate the overhead costs for safety injection systems, offsite power, and so forth, so that there is those regulatory requirements may appropriately be relaxed with assuring safety. Many of them would promise smaller and slower accident release. They have some of them have much smaller in terms of their size of the cores. That gives you the opportunity to relax the exclusion zone requirements, and that it might even open the possibility that some of these designs could replace coal plants that might be near populated areas because of the reduced risks from a possible accident. A really important factor that I don't think has been adequately discussed is that existing power plants have a lot of their security requirements that were imposed after the plants were built. And I was very much in the middle of that after 9/11. Greatly enhanced security requirements that imposes a significant cost because a lot of the personnel at nuclear plants are security personnel. There's an opportunity and a necessity with these advanced reactors to design in the security right from the beginning, and offering opportunity not only of greater security, but greatly reduced costs associated with the operating costs to maintain security. There's an opportunity to reduce the massive containments. Some of these reactors operate at atmospheric pressure so that the propulsive force for the wide distribution of radionuclides in the event of the accident is greatly reduced. And the NRC has opened the opportunity that you could perhaps relax some of the containment requirements. One of the huge costs for a nuclear plant is the construction of the massive reinforced concrete structures. If you can reduce those costs, that is by having systems that don't require those types of containments, then that's a huge advantage. Some of them are be factory constructed, greatly reduce cost for the actual construction of the plant, and that greatly reduce the financing costs, which is a significant component of the cost of a nuclear plant. And of course, many of them are smaller reactors, which just reduces the aggregate price tag for the reactor. These days, if you're building a gigawatt-sized plant, it can be a bet your company proposition for a vendor to acquire one, whereas the cost of a smaller plant might be more manageable and digestible by a company without imposing quite the same financial risk. So there's some huge opportunities, not only to improve all the dimensions I've mentioned, but associated with them is the opportunity to reduce costs in a very significant way, which is going to be essential for nuclear to penetrate in the US. However, you've got to deal with the regulations if this is going to succeed. The existing regulations were highly prescriptive as originally promulgated. They have an overlay of risk-informed elements that came because basically the capacity to do PRAs developed basically after a lot of the existing requirements were in place. There's been an evolving regulatory philosophy with the result that existing regulations are somewhat of a patchwork. And there's a capacity here to build in risk insights right from the beginning, with the aspiration to have regulations are technology neutral, which means they have to be at a very high level. But there's a great trick in being able to do this, because even though they're at high level, you need to have a process which is predictable, reproducible, and is sufficiently clear that a vendor knows what it's going to have to do to be able to satisfy the licensing requirements. And that sort of pushes you in different directions to have it be technology neutral, but still sufficiently predictable that a vendor knows what it has to comply with. That's going to be a huge challenge. Fortunately, there's a lot of work that's been done to help address that area. The aim is to have a risk-informed, performance-based, technology-neutral system, a licensing system. And there's been work that's been undertaken by DOE, NEI, the industry, through the licensing modernization project and through some of the follow-up activities to build in a process that used risk insights right from the beginning. And that's in the process of basically doing a lot of tabletop exercises to try to refine the process. But there is, fortunately, there's a lot of thought that has been put into a framework that enables possibly enables this whole process to go forward in a way that can speed up the licensing and give the clarity that the vendors need. Let me say also that it's my perception, and Mark will know this, and perhaps Paul as well, about better than I do, is that my perception is the NRC is trying to respond to this demand. The Nuclear Energy Innovation and Management Act, which passed in 2019, imposes an obligation on the NRC, and by statute it imposed an obligation to complete this technology neutral, risk-informed, performance-based regulatory system, which to be a new Part 53 by 2027. And the NRC has committed to try to complete that process by 2024. So it's trying to get something in place that will give the early guidance that's necessary. And in the meantime, the NRC is trying to accommodate providing as much early assurance as possible that it has been prepared to issue approve at staff level, approve technical reports, topical reports, approve exemptions, accommodate white papers, contemplates generic environmental impact statements that greatly simplifies the environmental impact process as a way to provide some early certainty to the vendors. It's not going to be as complete as Part 53 hopefully will provide, but it does reflect an effort by the NRC to accommodate the need to deal with the wide variety of interests that are expressed by vendors in very different designs than we currently have. So let me say, I think that we do confront a very severe licensing challenge that has to be dealt with, but there is great promise, I believe, to if we can pull it off, that we can deal with some of the central challenges to assure that nuclear is available in an important time to deal with climate change. Unfortunately, simultaneously, I think the political process is changing. I think that carbon policy is shifting in the public eye to include nuclear as an essential component. That's not to say that there aren't many that disagree, but I think that the role of nuclear that has to play in dealing with climate change has become increasingly central. So, and I think that's going to be absolutely, that's a huge effort that's going to be required to get us there. It's my view, it's essential that we do it. So that's an overview of what we're confronting, and I will turn it back to you, Paul, to continue the discussion.
Well, thank you. I'll go ahead, Mark. Why don't we start off with your discussion, and then we'll follow from there.
Yeah, thanks, Paul. Thanks, Dr. Meserve. Great comments. I agree with all of them. I wanted to build off of what you said, and especially that last part to frame why is it important that the NRC modernize the regulatory framework for new and advanced reactors, and then provide some sort of vision for the process of how to go about that. And so it really comes down to the fact that nuclear energy is important to the national strategy and achieving national goals within the areas of the environment, the economy, national security. As you mentioned, Dr. Meserve, there's growing recognition that nuclear needs to be the part of the solution for decreasing carbon emissions in the electricity sector. This goes along with utilities making commitments in this area and starting to realize that new nuclear, advanced reactors, has to be part of that solution. There's also recognition that we need to be bringing a decarbonization mindset to the broader energy. And when you look at the available technologies, nuclear, with its ability to have high heat outputs, is one of the best technologies to be able to decarbonize transportation and industrial processes. So in all of that, though, decarbonization has to be done in a way that ensures reliability and affordability of our energy. And that's why nuclear is so essential. And there's many studies out there that are confirming that fact, that nuclear has to be part of the solution of a reliable and affordable clean energy system. And then national security, as we look not just what nuclear can do within our nation's borders, but also as other countries around the world look at utilizing more nuclear energy or nuclear energy for the first time. We recognize that there's a choice, and that choice could either be for those countries to import Russian or Chinese technology, or they could import U.S. technology that along with it comes the safety and security standards that we've developed. And so that's very important. And I bring that up just to make sure that we understand that what's being discussed here is not just, I'll use a loose term, an academic pursuit for the sake of making things better. It actually has real impacts. The ability for the NRC to modernize and make more efficient the regulatory framework for new and advanced reactors has a direct impact on the ability to achieve these goals. We also see that we're facing new dynamics within the industry. We're seeing, as Dr. Meserve mentioned, great support from Congress, record level fundings for nuclear technologies, DOE just announcing awardees for their advanced reactor demonstration program, as well as an award to UAMPS for their project. And so we see that projects are becoming real, that there's more and more interest and perhaps more plans for applications, even in the near term. And that as we look longer term, broad scale deployment of nuclear is certainly a possibility. And so we see the demands from the regulatory services that are going to be needed from the NRC. And then finally, we see that many of the things that Dr. Meserve talked about in terms of the challenges that new technologies bring to the regulatory framework, but also recognize that even the licensing of reactors up till now have identified that additional efficiencies can be gained. Many of the technical requirements that were just discussed, but also in terms of how it impacts the cost and timing and risk of new reactors in the business world. And so that's one of the lenses we should look at through as we look at how do we modernize the regulatory framework, is we need to recognize that it needs to be more efficient so that the timeliness, the cost, and the predictability of the regulatory framework aligns with the needs of the regulated industry and the business environment that they operate in. And so with that, we even recognize that although the NRC has been making a lot of progress in terms of efficiency, in fact, the new scale design was reviewed slightly ahead of the target schedule, which is a great milestone. That even that target schedule could find efficiencies and be further reduced. Even within the reviews, we see that there's a lot of information that is provided and reviewed by the NRC that's not actually necessary. And so how do we get the right size or right level of detail within that? It brings in other things that I'm sure we'll talk about today in terms of the environmental reviews and citing. So very excited. I do want to mention, just looking at this in a long-term perspective, the NRC can license new and advanced reactors today without any changes. That's not the question. The question is how to do it more efficiently. And I'm very pleased to say that the NRC has been proactive in this area. They've been working since the early 2000s on how to prepare for and license new and advanced reactors. Some of the rulemakings that are ongoing, the emergency preparedness and the security that were mentioned earlier, came out of those early 2000 efforts. And as we continue to learn more about these designs and identify more opportunities for efficiencies, then additional issues are being added to the scope of the work. So with that, look forward to more discussion on this topic.
Thank you both. You know, this is an extraordinary undertaking if you think about it. In fact, I can't even recall when we've seen such an ambitious schedule laid out for what could be a very complex rulemaking. In fact, I would point out that Mark, your own association of industry folks, in your letter to the NRC said that you thought that 2027 was an appropriate time for this, but you'd be willing to support a rulemaking by 2024. So I also do want to read one thing which I thought I got a chuckle out of was that in your letter you also asked for the NRC to prepare regulations, and any necessary guidance should be written to avoid confusion and ambiguity. So there you made a double challenge. Not only are we shrinking the time frame, but we're also setting a standard for a lack of ambiguity and avoiding confusion. But you know, I really want, you know, there's a lot of pitfalls that come with this, and we ought to be prepared to address those. And so I guess I'd kind of like to get your opinions on where you see the bumps in the road. And you know, Mark, you want to start?
Yeah, thanks. And just to add some more background and color to those comments, that they really come from a perspective that this Part 53 rulemaking is essentially once in a lifetime opportunity. It's probably the biggest rulemaking that I'll ever see in my career in the nuclear industry. And if we look at similar rulemakings in the past that were important, Part 52 is one. That was back in 1990, so that's almost 30 years ago, and that took a decade, maybe even longer, to complete. And so we're talking about doing this in 4 years. And when you boil down the schedule, you really have a year to get the content of this rulemaking right. So that's the schedule challenge, I'll say, to this. And because this is a once in a lifetime rulemaking, and this is really going to be the rule that I envision most or almost all reactors past 2024 will want to be licensed under if we do it right. And so that means it has to be transformational. We need to be more than just improve the things that we can easily recognize from Part 50 and 52 today. And so that's the double challenge of being transformational, but it has to be transformational in a way that it's perfect. And so that's the triple challenge there that you just referenced. And so we're up to the task to providing our perspective and helping the NRC be successful. And I believe that they're up to the task as well. It will be a very fun journey to go on, and glad I'm very fortunate to be part of it.
Excuse me, let me hang up something here. My phone is ringing. Let me just comment. I think that, of course, you're correct, that 2024 is a very ambitious date by which to accomplish such a comprehensive and very difficult problem. Fortunately, as Marcus indicated, we have a running start, and that this has been something that the NRC and the industry has been contemplating for a long time. And there's activities like the licensing modernization project were intended to provide some capacity to feed into this process. That so it isn't like we're starting with a cold start here. No, it's going to be a huge challenge, but at least it isn't something that we don't have any idea how we're going to proceed. The other thing that I think is going to be essential for the NRC to do is that if it's not going to make mistakes, it has to be a lot of interaction with affected parties all the way through the process. That, you know, there's got to be a lot of openness that as they sort of grapple with issues. And I'm not talking about just with the vendors in the industry, but with those, you know, the stakeholders of all types have got to have some visibility into the process, and there's got to be a lot of flexibility in terms of interactions to be able to actually see the issues that the various parties see and address them along the way. You're never going to meet the deadline. And I'll just make a third observation that there is, I think that the guiding principle that should be used is a much deeper appreciation of risk and where the risk arises. The idea of relaxing requirements has got to be driven by you know, examination of the frequency and the consequences of events, and determining what has to be regulated and what doesn't should be guided by risk considerations, and that really has got to be the foundation for this if we're going to succeed.
You know, what you both brought up some very interesting points, and obviously underlying what you just said, Dick, was this you know, the performance-based regulation approach, which is going to have to be really driving almost everything that we look at. And I do want to also point out that one other part that was raised, and that has to do with the use of consensus standards, which I think we're also talking about as a way to kind of streamline and in order to make this this approach to do this in a faster form. And I say that because obviously this is one of the key elements of the NRC's approach to how they're going to be going forward on this. You know, and I am, you know, just getting back again to this idea of timing and being able to work these specific issues. You know, obviously the interaction with stakeholders is going to be essential, and that's going to be a difficult process to try to gather and resolve these comments. And Mark, I know you have a group. NEI is taking a significant lead effort and built a large group of people to deal with this. Can you explain how you see your engagement with the NRC going forward?
Yeah, I think that from a macro perspective, this is going to be a very intense effort, and so it's going to require a lot of resources on both the NRC and industry side. And so within that, we did form a task force specifically for this area. We're meeting weekly now to discuss that. And within this, we want to be able to respond to the NRC as they put together ideas and proposals for stakeholder feedback. But we also want to put together our own ideas and get them in front of the NRC early in the process so that they have time to fully consider what we're thinking about. The views of all stakeholders are all important. We tend to think that since we're being regulated by the NRC and we understand the impacts of regulations on the industry and these designs, that we have a unique insight into how these regulations can be developed in a very efficient way. And in terms of being performance-based, risk-informed, and that.
I agree with everything Mark has said. I do think there are going to be some special areas where there are going to be particular challenges. I think fuels could be a challenge for some of these reactors, in that, that we obviously have a lot of experience with existing light water, 5% enriched zirconium cladded fuel. We know all about that. But as we go forward and we go different types of fuels, much higher enrichments, different kinds of claddings, even in the case of some of the molten salt reactors, having the fuel that is dissolved in the coolant, you have a whole series of challenges. And the NRC has a process for evaluating fuels that takes time, because you need to test the fuels under accident conditions, because you need to have it irradiated sufficiently to be able to understand all the consequences as you go forward. And I think that's hard to rush that. So I think there are going to be there's a lot of work that's been done. The TRISO fuels, we actually do know a lot about them, and several of the reactors are including them. It's, a carbide form of fuel. It's highly safe. But I mean, some of these very different fuels are going to present some real challenges to be able to accommodate the vendor's need for early guidance as to what exactly is going to be required. I see that as a long pole in the tent for some of these vendors.
Yeah, that's a good point, and I agree with that. And I'll just put it in the context of these demonstrations in early reactors that are being developed, and DOE has a requirement for their ARDP program to be operational in 7 years. And so these designs are likely to use fuel that hasn't been approved by the NRC before. So we do have to, or the NRC does have to, develop a process that would allow that licensing within the required time frame, recognizing that in the past the fuel has taken 20 years or more. And for the future, that's not going to be the best approach.
Paul, can I ask a question of Mark?
Absolutely.
There's been an option that the NRC has put on the table that I would have thought might be of some interest to some of the vendors, and that is that the NRC has indicated they're very happy to license a prototype plant that you could put on a place like Idaho, distant from everywhere, as anyone who's been to Idaho National Laboratory would know. And you license it as a prototype plant. It may have some additional safety features that you build into that prototype, so you can actually build the plant. Look at all the integral effects of how the subsystems all interact with each other. You may not want to drive it to accident conditions, but you could do a whole lot of things that you can't do from separate analyses. Can validate codes beyond their current scope, for example, is essential for licensing. There's an opportunity, it seems to me, to use the prototype approach, have something with extra safety features that you test at a very remote site like Idaho, and then after you've proven that the safety features are appropriate, then you can back off to get the NRC to agree that you can operate at higher power or whatever. And it's always seemed to me that ought to be attractive to vendors, but I've never seen a vendor who's ever expressed any interest in doing it. And I'm sort of curious as to why the vendors are not grabbed this as an opportunity.
Yeah, that's a great question. And the first point is we think it should be an option. Absolutely, the developers and licensees should have that option. The reason that it's not the preferred option is because one, a lot of the developers think that they can demonstrate reasonable assurance of adequate protection of public health and safety without those additional features, and then two, adding those additional features, especially if they're not necessary for the prior statement, would add additional cost. And having many of these initial reactors as commercial reactors that have to compete in the market, that wouldn't be the preferred option. But certainly it is something that if it were required, to be able to demonstrate the safety, then it would be an option that we'd want to have.
It just seems to me for some of the really advanced designs, where you don't have a lot of experience, this ought to be a lower cost, faster path for some of the vendors. And I agree, for many, it's not necessary. You wouldn't want to do it if you don't have to. But I mean, it for some of the really far out designs, it might be a helpful approach.
Well, in fact, Dick, you know, I hate to say how many years ago this was, but I worked at the Idaho lab when we were doing the loft tests. And those are exactly what we're doing. We're using, in fact, those are NRC sponsored tests to try to improve on those codes for large break locus. So that's, I think I agree with you. Yeah, we've gotten several questions that have come in, and so we'll go to answer these questions. But before we do, I want to go back to something, Dick, that you said, which I think is important, because I also think the industry group has also acknowledged that you know, a technology inclusive rule would not exclude the licensing of other technologies such as large light water reactors. So if let's assume that we're successful and Part 53 is done and everybody loves it, how do you see this flowing over to large reactors or even to the current fleet?
Well, let me say, I was interested to see that the NEI letter that Mark sent about Part 53 did open the door. That, gee, we ought to consider this the rule for, you know, existing large plants, existing plants. I think that everyone contemplates that you would not remove Part 50 or Part 52. You'd have a Part 53 as an option. And I think a lot of the existing plants aren't going to want to mess with their licensing basis. They're just going to keep on going with where they have, and they're not going to open up to that. And you know, they might come in for a license amendment for some risk-informed adjustment of some requirement, but then they should do that. But they're not going to go exploit. I don't think the existing plants will exploit Part 53. I do think there is an opportunity, though, for, if we continue to build large light water reactors, gigawatt scale reactors, that it may be attractive for some of the vendors to take the opportunity that Part 53 could provide to use risk considerations as a vehicle for reducing some of the things that the NRC looks for in existing plants that we never have backed off of once we had risk on sites that said that, oh, gee, we're doing more than we need to in a given area, and to assure adequate protection of public health and safety. So I actually think that it actually would be attractive, perhaps, if somebody wants to build a huge light water reactor, to have the opportunity to use Part 53. I don't think anyone's going to be rushing to do it because they're going to make sure it works first. And I'm not sure we're going to build any large light water reactors given the local experience. But I mean, that's why the advanced reactors or small reactors are so attractive. But I for myself, would leave open the option.
Yeah, I completely agree with you. I look at it this way: if Part 53 excludes a particular technology, large light water reactors, for example, it's difficult to call it technology inclusive if it's being exclusive. So that's point number one. The other point is really understanding what we're trying to achieve, or at least from an industry perspective, what we think we should be trying to achieve with Part 53. It's not just a matter of being technology inclusive from the perspective that Part 50 and 52 has very prescriptive requirements, or they have requirements that are only applicable to large light water reactors. That's part of it. But if all we wanted to do was address that issue, we could probably write Part 53 in a month or two. That's not where the transformation comes from. The transformation comes from addressing the other issue of Part 50-52, which, and the NRC had said this in an earlier document, that essentially it's a patchwork of regulations that have been added and created over the years. And so what we're trying to do is look at it in a more modern and holistic way, such that as you put all of the pieces and consider them all together, and this would be safety, security, emergency preparedness, quality assurance, everything together, how can you make a more efficient safety paradigm? And so that's really what we're after, and that's the transformational piece, and that's what's going to take a lot of time. as Dr. Meserve had said earlier, we do have a running start. Okay, thanks. We've got the LMP and TCAP, Licensee Modernization Program, and that has given a lot of great concepts to this more holistic. But that's really just on the safety side. How do we weave in security? Security has always been treated completely separate. How do we weave in emergency preparedness? Emergency preparedness has sort of been tacked on as an extra layer and never really considered within the entire framework of things. And so I can go into great detail on sort of our thinking of the safety paradigm, but just to stop here and say, this is the transformational piece. How can we be more holistic and modern in our thinking rather than carry forward this patchwork approach?
Well, that's a great segue to some of the questions we have coming up. So Alan, what do you want to do? Do you want to ask people to respond, turn their mics on, or should I read the questions? How do we want to do this?
Sure. We'll start the Q&A portion. Again, my name is Alan On, Director of Programs, Communications at Gabi. Thanks for joining us. Just a reminder, if you would like to verbalize your question, please raise your hand, or you can submit your questions via chat through the Q&A button at the bottom of your interface. So again, if you want to speak up, I can unmute you temporarily. Please do raise your hand if you would like to do that. But I think we've had a few questions sitting in chat and Q&A for a while, so let's go to those and we'll pose these questions to our panel. Had a question from Warren, who has had a question here sitting for some time. This is a question for Dr. Meserve. You described a number of opportunities provided by the advanced reactors being considered, including minimal radioactive material release in the case of an accident. On the security side, many of these reactors will use significantly higher enriched fuel than current power reactors, perhaps requiring more stringent physical protection measures. Do you think the regulatory guidance that exists or is being developed is adequate to inform reactor vendors what physical protection measures they may need to take to seal these reactors, or do you have specific recommendations on physical protection regulatory requirements?
Well, you know, this is an area where the security requirements are ones that are in broad terms are described publicly, but a lot of the details are not public. You know, and the NRC has said that it is undertaking a limited rulemaking in this area, but I think a lot of the details are not public about what it's considering. The point I was trying to make is that there is, of course, it's going to vary from the reactors. No one's talking about the usage of highly enriched fuel in any of these reactors. The ones we've been just discussing. We're talking about reactors that will have enrichments perhaps up to or close to 20%, but below the high enriched uranium threshold. So they will have higher enriched fuel, which raises some of the safety considerations and conceivably raises some security related issues. But on the other hand, some of the reactors, for example, that are going to be deep underground, so they're going to be less vulnerable to an aircraft attack. You design in the vital areas right from the beginning and in ways that you can protect them more readily. Limited control, perhaps control access to those areas in a more efficient way than is found in existing reactors, because those weren't designed initially with security in mind. So there are lots of opportunities to reduce the security-related costs. I am not a party to any of the internal discussions about the security issues, so I don't know what the NRC is contemplating in this area, but it is very much something that is on the plate and is going to have to be addressed in the context of how we regulate these advanced reactors going forward.
Anything to add to this, Paul, Mark?
Yeah, I agree with. with Dick, yeah, and in terms of security and as in the design basis threat against the plant, that would be adversaries to attack it. The NRC does have a rulemaking ongoing that would recognize what Dick had mentioned earlier, which is security by design, and how to address that. And we at NEI are developing guidance that would help to implement that limited scope rulemaking. Within the context of theft and diversion, as Dick mentioned, this would still be low enriched uranium. And so while we may look at whether additional protocols are necessary, we're not anticipating any at this time.
Have a question from Andy Zach, Senate EPW committee. And I think this is primarily directed at Mark, although obviously the rest of our panelists can chime in. Why do you believe that it is an either or of fast or transformational? Should we not be asking NRC to be the most transformational as expeditiously as possible? Is there any tension or mutual exclusivity between these two imperatives?
Yeah. So I agree with the sense that yes, we should be asking the NRC to be both transformational and fast in their activities. That is our desire. The challenge, and I'll say it's not in this case, it's not an either or. We do think that we can be transformational within the 2024 final rule. So it's not to say that we can't be transformational. It's that it's an additional challenge. And I look at it from two perspectives. There's a critical path timeline, which is a sequencing of activities. And certainly that's part of the issue. But greater than that is the level of effort that's required, or the total man hours, I look at it, that's needed to be transformational. And so you're squeezing in all those person hours into a short time frame. And so while we're ramping up to be able to provide those person hours and support the rulemaking, and I'm sure the NRC is as well, what we're now looking at is how does that impact other work, including near-term work that we may have prioritized and would have benefited Part 53 in the long run. We're asking ourselves, are those things that are now need to be displaced and need to be deferred or delayed until so that we can focus more resources on Part 53. That's sort of the issue at hand.
Let me add this one thing. Is that, first of all, I think the answer to Andy's question is that of course they should be both. But let's focus on the fast for a second, because as we know, rulemaking is a process, and that process has interactions that sometimes the NRC and the industry can't control. That's obviously intervention. So part of what you have to do is you have to be careful as you move forward that you're laying out a process and a path that is not only transparent, but it's also something which people can recognize as being addressing the issue. So that's the only thing I can see coming forward here, because I actually believe very strongly that the NRC right now is positioned to address a lot of these things and has been working on this for a long time. But you know, rulemaking is still a process, and there's things you can't control.
Let's move on to the next questions from Matt McKenzie of NRDC. I think it gets to perhaps the prototype approach, which Dr. Meserve raised earlier. He'd be grateful for the panel's thoughts on the following proposition. Quantitative evaluation of safety performance needs to be thoroughly validated with actual plant operating experience. For example, a gigawatt scale molten salt reactor is very far from current operational experience. Regulatory decisions should be made on high quality experimental data and conservative assumptions. A full regulatory regime for an advanced nuclear design will require data from a prototype, likely from a first of a kind. Any thoughts on that statement?
Well, let me say that's why I raised the question about prototypes, because I think that there are likely for some of the designs, we're going to get beyond the scope of the validation of codes, beyond the scope of the existing data, and prototype plant may be a vehicle by which you could gain the necessary information to give both the vendor and the NRC comfort that that you're in a regime where you can reliably predict what's going to go on. And that may not be necessary for many of the designs. We know a lot about tricycle fuel, for example, and many of the designs would use tricycle fuel, so we won't need it there. But you know, for some of the other advanced fuel designs, for example, there may well be a need for additional data, and prototype plants might be, in my view, an appropriate vehicle for at least some of the designs to be able to resolve some of those questions. So I agree with the thrust of the comment.
Yeah, it's an important point and consideration in going through this. A couple of thoughts. One, the quantitative method, so probabilistic risk assessment, does have a process for handling areas of uncertainty that where you wouldn't have as much operating experience, and being able to work with them within the quantitative framework. The other is that we're encouraging the NRC to not be completely risk-based, and that this risk-informed approach would also allow for the flexibility to use some deterministic approaches if applicants would like to do that. You know, we've seen the Oklo application was a very deterministic approach that went in. There may be ways to use deterministic methods within quantitative approaches to be able to address situations like this. So flexibility here is going to be very important as well.
Yeah, let me say, Mark makes a good point that there may be, through probabilistic techniques, you may be able to extend into regimes that you haven't got assured data. But the way you handle that is by additional margin. So you have confidence that you have limits that are highly unlikely to be exceeded. That may mean that when you really build the plant, that you have imposed requirements that are unnecessary or excessive for what the actual experience is. So there's a trade-off that has to be made. Do you live with uncertainty and deal with it by lots of additional margin to protect yourself, or do you get real data and use that to guide you?
Yeah, that's a good point. And back to our earlier discussion on the prototyping option, and so that could be part of the consideration of developers, where, well, rather than using prototyping provisions and adding features that add additional costs to the plant, what if we just add additional margins and design things in? So it could be, you know, sort of another option within that.
A quick follow-up. Got a question from Ed. Who would invest in a prototype? Wouldn't this have to be the government? It's from Ed Key of NECG.
It wouldn't have to be the government. I think most people look at the government as the likely investor in a prototype. And what Ed is hitting on is, if it's a prototype and it's not generating electricity for sale or energy for sale, and so therefore it's not making revenue, it's entirely a cost burden, then who in private industry would build it? There are companies that are looking at privately funding a demonstration plant that would not earn revenue. To my understanding, that's the Oklo plans for their current application to demonstrate a plant at INL. I believe that that's not a revenue generating plant, and they're entirely privately funded. So there are entirely private options, but the government is also one that most people look at.
Well, I believe, Mark, the Oklo is a microreactor, so it's presumably very low cost to make a prototype. It doesn't have anything like the cost we're talking about for something that's going to on a major grid.
Yeah.
Have an interesting question here from Jennifer Heimberg of National Academies, and I think this would have been my question to your point earlier about the challenge of fuels, Dr. Mazur. Regarding the challenge of approving new fuels by the NRC, do you see an operational versatile test reactor as part of a critical path to licensing of new advanced reactors?
Well, much of the justification for the versatile test reactor is to have loops in it that will provide a variety of different coolants and exposure circumstances, so you do have a capacity to test fuels of various types that are appropriate for different kinds of reactors. And I believe that's supposed to be will itself be a sodium-cooled reactor. But they intend to have test loops for various other coolants and other variables so that it does provide a versatile means to deal with the fuel issue. But remember, you've got to build that reactor first. You've got to then get all the test loops operating. You've got to get the fuel in it. You've got to expose the fuel. You've got to go through your test protocol. So we're not talking about anything that's going to be near-term response to some of these vendors' interests in being able to move forward relatively quickly.
Yeah, and what I hear from the advanced reactor developers is that the VTR is not required to be able to license their designs. It is, Dick mentioned, that the timelines for the VTR are such that, that's a good thing, because many of these developers want to license their designs before it would be available to test fuel. The value in the VTR is comes in the operation phase, to be able to extend the operating parameters of that fuel, to be able to extend the lifetimes of the fuel, make it more efficient and cost effective.
Sure. Certainly.
Independent of this, there's a lot of work on accident tolerant fuels anyway, and if that, I'm sure, will continue as you go to various these other types of reactors. And so there is, follow-on fuel forms that may be of interest for these reactors that enable some further relaxation of requirements that might be initially have to be imposed.
Yeah, and we do have the ATR, Advanced Test Reactor, and other capabilities to test fuel. And in fact, even in my recollection of the TRISO fuel validation work, their critical path was having access to the ATR to be able to do that work. So.
Got a few questions remaining and not a whole lot of time, so perhaps we can I'll just pose both of these questions that we have outstanding, and then perhaps we can close out the webinar after that. A question from Isaac Kim of JP Morgan with regards to safety features against accidents. Any thoughts on the role of artificial intelligence, current deployment of AI and nuclear power generation? And an anonymous question about how advanced reactors could complement variable renewables through load following, automated control by ISO RTO operator would provide faster response and make this capability both more valuable and more competitive than natural gas. Could you comment on the licensing issues associated with this? So we'll probably answer these collectively as well.
Yeah, I can take on both at the same time. So for the integration with renewables and even integrated energy systems that might look at heat storage or hydrogen production, much of what developers are looking at, especially for these advanced technologies, that these balance of plant systems don't have any impact on safety. And so therefore, we're looking at how these balance of plant systems can be excluded from the NRC safety review if they don't have any impact on safety. And so from that perspective, there is a possibility that they don't even factor into the licensing. On the AI, this is something that has started with microreactors, will likely go to other reactors. They're looking at how can they have automatic operations, which could factor in some artificial intelligence. That will be a licensing consideration. So if you are transferring the function of operating the reactor from humans to equipment, or in this case, AI, that's certainly a technical issue that the NRC is going to want to look into.
Let me respond quickly on the variable renewables. I think it's inevitable that we're going to have more and more renewables on the grids. And the nuclear part of the grid is going to have to complement them in various ways. Nuclear plant makes money if it's operating all the time. So that means that to complement the renewables, you need to have storage capability, or you need to have co-products that are produced that when you don't need the nuclear plant, you're using the power in some productive way. The advanced reactors have the promise of opening up opportunities that don't exist with existing plants, both because they can ramp up and down in many cases much faster than existing power plants and then can fill in easier, but also because they operate, many of them, at higher temperatures, that there are opportunities for process heat applications, production of hydrogen, or what have you, that are open up economic opportunities that make the nuclear plant more viable. So, I mean, I think that one has to think about advanced reactors in that context as well.
I think we're out of time, Alan, and I'm going to turn this over to Florence for, and thank you all. This has been very good. We still have some questions, but we'll have to save that for the next one, Florence.
If there are any remaining questions, please email me, and perhaps we can make email introductions. But thank you so much to the panel for this wonderful conversation.
Obviously, this has been a hot topic, and we had the right people in the room, and thanks, Paul, for making this exciting. I don't know about fun part. This is not a fun topic, but we have a really informed audience who has the right questions and experts to answer. So we had a really exciting, engaging dialogue. So thank you so much for joining Gabby, and look forward to seeing you next program. Thank you.
Thank you.
Thank you so much.
Thank you.
Thanks.